Hello, good afternoon, everyone. First of all, a small cross check. Please, just let me know if my voice and my is audible to you and my video is visible to you. All right, thank you so much. So I ended last class with these questions, isn't it? If you guys remember, I ended last class with these questions. So I'll start with these questions only. With the discussion of these questions, then we'll do further more questions. Got it? So let's begin. See, the first question you have is x dx. First question is integration x dx upon under root of x square minus a square into b square minus x square. See, it's very much clear that the derivative of denominator like x square, it is there in the numerator, isn't it? Denominator, in the denominator, there is x square and its derivative is there in the numerator x. So I'll do one thing. Let us assume that x square minus a square as t square. X square minus a square as t square. So it will be 2x dx equals to 2t dt. 2 cancel. So it is x dx is t dt. Am I correct? So it became t dt upon inside the root x square minus a square is t square and b square minus x square will be b square minus a square minus t square. Got it? Now this t square will come out, t cancel. So this goes integration dt upon under root of b square minus a square minus t square, to which I can write dt upon inside the root. It is under root of b square minus a square whole square minus t square. And this is what integration of sine inverse t upon under root b square minus a square plus constant. This is it. Got it? And a very good question. With good as well as important question. Now next is x square dx upon under root में integration x square dx upon under root a to the power 6 minus x to the power 6. Now if you realize numerator is having x square. All right. So denominator में if I take x cube as t, its derivative is there in the numerator. So if x cube is t, then 3x square dx will come out to be dt. So this x square dx I replace by dt upon 3 and inside the root a to the power 6 minus t square. Am I clear? This is again going sine inverse formula. So it is sine inverse of t upon a to the power 3 plus constant. And t you can replace finally by x cube. So it is 1 by 3 sine inverse of x cube upon a cube plus constant. Easy? Well, very good. Now the third question is also of the same type. All you have to do is x to the power 3 by 2. Take it as t. Take x to the power 3 by 2 as t. Am I clear? Now come to fourth one. Fourth is dx upon under root of x square plus x minus 2. Yes. See, as such, this quadratic can be factorized. Yes or no? But that does not solve my purpose. So what we have to do? We have to complete the square inside it. So dx upon under root of x square plus x plus 1 by 4 minus 1 by 4 minus 2. So dx upon inside the root x plus 1 by 2 whole square minus 9 by 4. This 9 by 4 will be 3 by 2 square. So it became x square minus a square. Its formula is, I have told you, this is. Formula is this, ln of x plus under root x square minus a square. So here it will be ln of x plus 1 by 2 x plus 1 by 2 whole square minus 3 by 2 square plus constant. This is your answer. Am I clear? Is it okay with everybody? You may respond in chat box, give thumb impression.
Okay, yes, sir.
Very good. Now, next question was sine to the power 4x cos to the power 4x. I equals to integration sine to the power 4x cos to the power 4x dx. Okay, I write it 2 sine x cos x whole raised to the power 4 upon 16. Basically, I multiplied and divided by 16. So it came 1 by 16 integration sine 2x whole to the power 4 dx. Now we will go slowly with the process. I have a formula that sine square theta is 1 minus cos 2 theta upon 2. Yes or no? So the sine square 2x ko I can write 1 minus cos 4x upon 2 whole square dx. Now along with 1 by 16, 1 by 4 also came out. You expand this perfect square to 1 plus cos square 4x minus 2 cos 4x dx. So 1 by 64 integration 1 minus 2 cos 4x. Now also I have a formula that cos square theta is 1 plus cos 2 theta upon 2. So it is 1 plus cos 8x upon 2 dx. 4x ka double angle of 4x will be 8x. So it is 1 by 64, 1 plus 1 by 2 comes 3 by 2 minus 2 cos 4x plus half of cos 8x dx. So finally you have 1 by 64. This will be 3x upon 2 minus 2 cos 4x integration will be sine 4x upon 4 and half of cos 8x integration will be sine 8x upon 8 plus constant. Have a look at it. See both the formulas and try to absorb it. Everybody got it? Now, there was another question. 27 e to the power 9x plus e to the power 12x whole to the power 1 by 3. 27 e to the power 9x plus e to the power 12x whole to the power 1 by 3 dx. Any idea? Anybody would like to present something? Some idea if you have? See, you can take e to the power 9x common. Yes or no? Got it? So if I take e to the power 9x common, it will be e to the power 3x outside and 27 plus e to the power 3x whole to the power 1 by 3 dx will come. Am I clear? So now you can substitute, like if you assume e to the power 3x as t. So 3 e to the power 3x dx will come as dt. So it will be 27 plus t to the power 1 by 3 into e to the power 3x dx will be dt upon 3. This integration will be 27 plus t to the power 4 by 3 upon 4 by 3 plus constant. Got it? This 3 and 3 will cancel out. Your answer will be 27 plus e to the power 3x whole to the power 4 by 3 upon 4 plus constant. Am I clear? Now we will do integration by parts. Now, the way we have a like summation rule of differential product rule of derivative, in the same way we have a product rule of integration. Like if there is integration fx into gx dx, fx into gx dx. Now we will assume one function as first, another function as second function. This first and second can be taken in the order by the rule, no, not a rule, I should say, by a convenient way, I late. And I is what? Inverse function. Inverse trigonometric function. L is what? Log function. A is algebraic. T is trigonometric. And E is exponential. Got it? So if there is a logarithmic and a trigonometric altogether, you are going to assume logarithmic as first function, trigonometric as second function. As such, this is not a hard and fast rule, but in some cases, it actually helps. So see, fx into gx dx, it is what? First into integration of second. First function multiplied by integration of second minus integration derivative of first integration of second whole integration. Got it? I do remember it like first function d by dx of second, sorry, first function into integration of second minus integration derivative of first into integration of second and whole integration. So if you try to remember it like this, it will be easy to remember. Got it? Now, like you want to integrate x cos x. So which function should I assume as first function? Algebraic first, trigonometric second. So it is first integration of second. Cos x integration is sin x minus integration derivative of first 1 integration of second sin x and then dx. So it is x sin x minus now integration of only sin x, that is minus cos x. So the answer is x sin x plus cos x plus cos 2. Am I clear? Now say you want to integrate ln x. Now if you realize there is only one function, there is no second function. So what do we do in such case? We take one along. Got it? Now integrate. Assume this one as first function ln x, one as second function. So first integration of second, one का integration x minus integration derivative of first ln x derivative 1 by x integration of second x dx. So it is x ln x minus x plus constant. This will cut, you will get 1. So it will be x ln x minus x. Got it? So answer is x times ln x minus 1 plus constant. Now see, I'm writing two questions for you. Integration tan inverse x dx and second is integration cosec square x ln sec x dx. Try them. Quickly try. Got it? Now see, again, in tan inverse x, we will assume 1. And take it as first function tan inverse and 1 as second. Tan inverse is in inverse category, 1 is in algebraic category. So first, integration of second x minus integration, first derivative. Integration of second x dx, isn't it? So it is x tan inverse x minus integration. I can write it 2x upon 1 plus x squared dx and half of this. I multiplied and divided by 2. Now what it is? X tan inverse x minus 1 by 2. Now it is ln of denominator plus constant. Got it? Ln of 1 plus x square plus constant. Now the second one. Integration cosec square x ln sec x dx. So now ln and trigonometric. So assume this one as first, this one as second, because we are aware of the integration of cosec square x. So it is first integration of second, cosec square x integration is minus cot x minus integration derivative of first. First derivative is 1 by sec x into sec x tan x. Second integration minus cot x dx. Am I correct? So here sec cancel, tan and cot cancel. So minus cot x ln sec x plus x plus constant. This will be your answer. Check quickly. Got it? Now, see we have another variety. I equals to integration sec cube x dx. I equals to integration sec cube x dx. Now in such kind of question, what do? We split this only function as sec x into sec square x dx. Now assume this one as first, this one as second. So first integration of sec square x is tan x minus integration derivative of first. So derivative of sec x is sec x tan x, integration of second tan x dx. Am I correct? Now it is sec x tan x minus integration sec x into tan square x dx. Sec x tan x minus integration. Now see, I write this sec x as it is and this tan x as sec square x minus 1. Got it? So it is sec x tan x minus. Now there will be two different terms. One is sec cube x dx. Other will be integration of sec x dx. Now you started this question with I and this again came as I. Yes or no? So you take this one to the left side, you will get 2I equals to sec x tan x plus integration of sec x is ln of sec x plus tan x. So I came what? I is half of sec x tan x plus ln of sec x plus tan x plus constant. Got it? Have a look. Am I clear? Now, next. I equals to integration sine of ln x. This question came in JEE multiple times. Sine of ln x dx. Again use by parts considering 1 as a second function. So 1 into sine of ln x dx. So now this is your first, this is your second. Got it? So first is second integration x minus integration. Derivative of first. Sin ln x derivative is cos ln x into ln x ka derivative 1 by x. Integration of second x dx. Now this x is 1. So now you have x sin ln x minus integration cos ln x dx. Again assume 1 as first function, this is first, this is second. 1 as another function and again apply by parts. So it is x sin ln x minus. Now see first integration of second x minus integration derivative of first minus of sin ln x upon x integration of second x dx. Now see this x cancelled and this entire integration became what you have started. So 2y will be what? X times sine of ln x plus cos of ln x plus cos. Have a look. Very good question. Got it? Done? Everybody got it? Someone reply, please. Now, see, there is a form if you sometimes see integration e to the power x and fx plus f dash x. So you don't have to simplify. Write answer directly e to the power fx plus constant. Got it? And e to the power, sorry, fx plus x f dash x dx. If you could identify an integration of this type, so answer will be directly x fx plus constant. Got it? Now write down the question. Yes, how to do? Try once. Now see, I can write in the numerator x plus 1 minus 1 e to the power x upon 1 plus x whole square is e to the power x. Now see, x plus 1 upon x plus 1 whole square will be 1 upon 1 plus x and minus 1 upon 1 plus x ka whole square. Now if you realize, if this is your fx, if this is your fx, then take this positive sign minus sign here. Then this is what, if that is fx, then minus 1 upon 1 plus x whole square is what? F dash x. So answer will be simply what? X fx. So it is e to the power x upon 1 plus x plus constant. That's it. Got it? Next. Yes. How to do? Now see, if I take this as fx, means fx is what? Ln of ln x. So what will be f dash x? F dash x is 1 upon ln x into derivative of ln x is 1 by x. Take this x to the left side. So it will be x f dash x is equals to 1 by ln x. That means if it was fx, so it is x f dash x. Answer comes what in such case? X f x. That is x times ln of ln x. Got it? See another question. Again, if you see that this is fx, then you will see this is x f dash x. So answer is simply what? X f x. So x times sine of x. Got it? Am I clear? Now, there comes a type of question, integration a to the power ax sine bx dx. So it will be e to the power ax upon a square plus b square, a sin bx minus b cos bx plus c. E to the power ax upon a square plus b square. So it is a sin bx minus b cos bx. And one question I will do. Integration e to the power 2x sin x dx. Yes or no? Now let's apply by parts. First, integration of second. Sin x integration is cos x. Derivative of first, 2e की power 2x. Integration of second, it's sin x integration minus cos x. So it will become plus cos x. Now again applying parts by parts on these two. पहला, integration of second plus sin x. Derivative of first, 2e की power 2x. Integration of second dx. Got it? Now if you realize, this came, not this one, sorry. This came as I again. So I is what? E to the power 2x minus cos x plus 2 e to the power 2x into sin x, and minus it is 2 and 2, 4i. Take it to the left side. So 5i equals to plus cos. That's it. Now divide by 5, you will get your answer. This is not cosec, this is cos. Am I clear? Now, see a very important variety of question. Numerator में you are having 1 plus x square. Denominator में you are having 1 plus x to the power 4. You want to integrate it. Any idea? Anybody who would like to try it? Yes, anybody would like to speak something? See, take x square common from the denominator. You get x square plus 1 by x square, and numerator में it is 1 plus x square dx. Yes or no? Now, first of all, divide by x square, it will be 1 plus 1 by x square dx. In the denominator, it is x square plus 1 by x square. I subtract 2, I plus 2. Which one I consider for completing the square? That depends on the numerator. So it is 1 plus 1 upon x square dx. Denominator में it is x minus 1 by x whole square plus 2. Now let us assume x minus 1 by x is t. So 1 plus 1 by x square dx is dt. So it is dt upon t square plus 2. So its integration is 1 upon root 2 tan inverse t upon root 2 plus constant. So it is 1 by root 2 tan inverse of t was x minus 1 by x by root 2 plus constant. See this. And in the meantime, reply for my query. I'm starting a poll. Please reply for it. Got it? Now, there is a very popular question, that is integration under root of tan x plus under root of odd x dx. You want to integrate this. Got it? So first of all, I write it root tan x plus 1 upon root tan x dx. That is 1 plus tan x upon root tan x. Am I correct? Now, let's do one thing. Multiply and divide by secant square x. And the denominator of the secant square you have, write it 1 plus tan square x. Got it? Now, take tan x as t square. Then sec square x dx will be 2t dt. So it is 1 plus t square upon 1 plus t to the power 4. Denominator mein it is t and sec square x dx will be 2t dt. This tt cancel. So you are left with 2 integration 1 plus t square upon 1 plus t to the power 4 dt. Now this is same question which we have done here. See it once. Got it? So that would be all from me today. Practice integration from any of the source you are having. Even the NCERT miscellaneous exercise is very good. Am I correct? So definitely go through it. It will be really, really helpful to you. All right. Anyways, thank you so much, guys. And see you in the next class.